speaker for this session is Tahnée Engelen. Tahnée is at the École Normale Supérieure in Paris, and she's going to be answering the questions: do neural responses to heartbeats distinguish self and other in an emotional perspective-taking task? Thank you, Tahnée.
Yeah, thanks for the introduction. So indeed, in this project, we were really looking at these neural responses to heartbeats and whether they might provide a mechanism for self-other distinction, specifically in emotion context. So this kind of nicely taps into the talk we saw previously, where what we were really interested is this idea that, so this was a recent viral photo, that we have one person who is clearly very, very angry, and we have a person who might be evaluating that anger, but he himself is able to distinguish that the fact that the other person is angry is not his own anger, and he's capable of taking into account that that's not something I need to take on myself. But then the question is really, how are we capable of doing this, given that it's such kind of a crucial mechanism? So the mechanism that we wanted to investigate here is specifically related to neural monitoring of heartbeats. So why would heartbeats be relevant for our sense of self? There are a couple of interesting characteristics in the heart. So we know that the heart is capable of generating contractions independently of the brain, and it does so continuously. So we have this little intrinsic oscillator in our body that is continuously sending ascending signals of those contractions to the brain. So this gives us a sense of what the state of our body is and whether we're healthy and doing well. But this is also a signal that is private. So only I am receiving this specific information continuously throughout my day. So how can we then quantify, like how do we quantify neural monitoring of heartbeats? We do that with so-called heartbeat evoked responses. So this is an example of intracranial data where we have our different time series of brain signals. And if we analyze these brain signals and we log them to specific cardiac events, so in this case, it's logged to the cardiac R peak, we can kind of generate these potentials, which are transient changes in our brain signal. And there's been some previous studies that showed that in a different context, they might indeed provide a marker for our sense of self. So just to give you one example, this is a study where participants were engaging in mental imagery, which was either self-oriented or other-oriented. And indeed, if we look at our heartbeat evoked response, there is this period in time specifically locked to the heartbeat where self and other are being distinguished. So the question we were asking is, can we see a similar effect in heartbeat evoked responses when we're judging self and other emotions? So the task we use for that is an emotional perspective taking task. And the important time point is here during task instruction. So participants learned these two symbolic cues, which were representative of either self or other. And they were preparing to rate an upcoming image. So these were naturalistic social images depicting people in different states of valence and arousal. And then for each trial, they would rate either how do you feel when you're exploring this image, or how do you think the person in this image is feeling right now? And these were rated on two behavioral scales, so continuous valence and continuous arousal. And before I dive into the main research question we had, I want to show some results on the stimulus period. So here people are really freely exploring the image, and we had a couple of physiological measures. So we were looking at facial EMG and skin conductance responses. So we used the GLM to model these responses during image viewing. So we were using the valence rating, the arousal rating, whether they were rating for self and other, and the interactions. So if we look at the zygomatic muscle, which is responsible for basically contracting with positive valence, we find a widely reported effect in the literature. We also find effects of arousal, but then interestingly, we also found an interaction between self and other and valence. So somehow the amount that this muscle is responding depends on whether you're rating an image for self or for other. And then our other measure was arousal, was skin conductance, where we find this kind of typical arousal effect, but we also found a self-other effect. So rather late in this exploration phase, we see that there's a stronger skin conductance response when people are rating self compared to other. So we were quite interesting to find these kind of objective markers of self-other distinction in our physiological ratings. And I just want to emphasize, since we're modeling this with a GLM, that these are quite, so here we are accounting for the variance attributed to the rating. So this is kind of a pure self-other effect that we're looking at. So the main question that we had was about heartbeat evoked responses. And now we're really looking at this task instruction window rather than the stimulus window. And the way we computed our heartbeat evoked responses was by looking for candidate R peaks during this particular time window when participants are preparing for their rating, and then locking our EEG analysis to these particular heartbeats. And then we can do a cluster-based permutation test where we're checking for differences between self and other. So if we look at our HER effects, which are here on the left, 0 in this case is locking to the R peak. We find around 420 milliseconds, indeed a significant difference between self and other ratings. So this is in the preparation phase. And to give you an idea about inter-individual variability here, these are just the average in the cluster per participant for self and other. And we find that this cluster in terms of space is right frontally localized. And I don't have time to go into all the control analysis, but I just wanted to quickly say that we did a couple of checks to make sure that our effects were truly HER effects and not attributable to other self-other differences. So we checked for differences in interbeat interval between self and other in the ECG in general. We also verified that the EEG effects were truly locked to the R peak and not general EEG effects during this Q period. And we also verified that these effects couldn't be explained by differences in alpha power between self and other. So we were quite pleased with these results, but we wanted to dive a little bit more into inter-individual differences and if we could explain somehow whether there are participants who might be having these effects more strongly than others. So to be able to do that, we did a source reconstruction which focused on self-other really during this particular time window. And then there were two things we wanted to explore. So first of all, these physiological differences we see in self and other in the skin conductance and the EMG, are those related to the effects we see in the heartbeat evoked response? And then secondly, are there any traits that participants might have that emphasize or strengthen these effects? And we did not find any results or correlations with our physiological measures, interestingly, but we did find that we had this cluster in the frontal operculum, which was dissociating self and other, which was significantly correlated with empathic concern. So this is one of the subscales of the interpersonal reactivity index. So to conclude, we see that it's potentially, it's possible that this neuromonitoring of heartbeats could provide a mechanism for self-other distinction in cases of, or in emotional context. We did find differences for self and other also in our peripheral physiological measures. And then lastly, we were able to show that there is some relation between this self-other distinction, which is locked to the R peak, which correlates with trait empathy, specifically in the frontal operculum. So I would like to thank my amazing co-authors for joining me into this project. Also thanks to Neuromatch and thanks for everyone that was listening.
Thank you very much, Tahnée. We already have a question here from Klaus Lam. You can unmute yourself to pose your question.
Okay. Okay. Thanks for a nice talk. Can you hear me? Yes.
Yeah.
Yeah, sure. Cool. So I just wrote it out anyway. Can you maybe explain a little bit more why exactly you looked at the instruction period? So wouldn't the logic be that you need the self-other distinction when you're looking at the images? I mean, the instruction is pretty much a heads up to what's coming next, right? So why is this the crucial period of analysis?
Yeah, so that's a really good question. There's two reasons for that. One of them is that we were kind of expecting that during the image viewing, we would have changes in heart rate, which would be a confound in our HER analysis. And then secondly, we were particularly interested when people are kind of preparing to be in a state of mind to make self-other distinction. And we wanted to then see whether this would be related with anything that is actually happening after you've already made this distinction. So let's say you put yourself into a certain reference frame. How is this related to how later on you're kind of processing the information presented to you?
Okay. And did you ever look at the later phase? I mean, is that something you're planning to, or is it really like, okay, this is a period we should not bother with because it's noisy?
It's something, yeah, I think it's something I'm still planning to, but I think, so I haven't gotten to it yet, and it's something where we have to think really carefully about how we can properly control, because also another thing that I maybe didn't mention is that they were free viewing these images, which for EEG makes it a little bit difficult to get a clean analysis there.
Oh, okay, I see. And the other aspect, sorry, maybe I'm taking too much time. If there are other questions.
We're good. We are well on time.
Okay. So the other thing, just to comment, I mean, the questionnaire measure is empathic concern. So I would not call it empathy in the sense that we use it. It's rather a sympathy or concern for others, but it makes even more sense in line with your prediction in the sense that people. So if I understood that, maybe you have to also decode that a little bit more. So the higher you are in self-reported trait, empathic concern, meaning how much you care for others and how much you support them indirectly, the lower, the more negative your self-other distinction in the frontal operculum, which means what exactly?
Yeah, so in this case, the coding of the analysis for the frontal operculum is that it was other versus self. So it's basically if it's a positive value, it means the activation in the cluster was stronger for other than for self.
Okay.
But I do have to say that just in general with the EEG and the source reconstruction, it's kind of difficult to give meaning to the sign of these effects.
Yeah, sure. Okay. But I guess what you would want to say on a conceptual level is that those who are higher empathic concern are better or worse in this self-other distinction index, which means listening or detecting your heartbeat.
It's a good question. I'm not entirely sure yet. This is something, so I wasn't necessarily expecting this result, and I'm still very much thinking and brooding on it.
Yeah. Because this is a tricky question, I mean, that we have also been thinking about quite a lot. So is it good to have clean self-other distinction, or is it bad? And probably there's some sort of U-shaped relationship.
Yeah, exactly.
So if you're very high on empathic concern, you might show a different pattern than being very low. And then there's the middle grounds where, so it's tricky.
Yeah, exactly. That's also the feeling I was getting from it.
Yeah.
Thank you, Klaus. We have a number of other questions. Nadine is next. Nadine, we can hear you, I think.
Okay, cool. Hi, thanks for the great talk. I just saw that my question is kind of similar to the one that's just been asked in the chat by Rebecca. But basically, if you can elaborate a bit more on the mechanism that you think might underlie this effect. So is it the case that people just pay more internal attention to their internal physiological signals when they are monitoring their own emotions, or do you think the causality is reversed somehow? Just some more ideas.
Yeah, so that's a really good question. And I do think it's very interesting to speculate about this idea that, of course, we're asking participants specifically, put yourself into a self or an other state of mind. And I don't have any measure in my study that I can prove that they are indeed paying more interoceptive attention, but I would think that this somehow is playing a role because of course, the whole point is that if you're evaluating your own emotion, you're listening to your body, so to say. So even though this is something I can only kind of speculate about in these particular results, I would think that this is playing a role.
Okay, yeah, thank you. Yeah, just in general, whether you think that is kind of the driver behind these kinds of effects that you see?
So I do have to kind of distinguish between the fact that here in this study we're looking at interoception in a non-subjective way. So this is really a physiological interoception where whether we're aware of it or not, the brain is kind of listening to the heartbeats. And it's always a question in how far this would correlate with our subjective measures of interoception and how good are we actually in monitoring our heartbeats.
Oh yeah, fair enough. Yeah, that's interesting. Okay, cool, thanks.
Thank you, Nadine. Rebecca, did you want to follow up on that, or do you feel like your question's been answered?
I think, yeah, it was kind of the same question actually, so thanks.
Awesome. Then we have one more question from Thomas. Thomas, I've allowed for you to unmute yourself if you wanted to ask your question yourself. Hi,
thanks. Great talk. Would you mind showing again the slide on the effect of the heartbeat related potential?
Yeah, this one?
Yes, so if I understood well, what you have is an increased response for other versus self, right?
Yes.
And I was wondering whether you would have expected the opposite effect, like when you're concentrating on the self, you potentially expect increased sensitivity to your own heartbeat.
Yeah, that's a really good question, where again, I kind of have to say that interpreting the sign of these signals is a little bit difficult. And I would also just like to point out on this topography here that we actually always had two co-occurring clusters, which were doing the exact opposite thing, but at the same time. So we have this kind of left parietal cluster where if I would have, so this was not significant, I have to say, but where I would have plotted it, we would have seen the exact opposite effect, but in the same time window. So it's a little bit difficult for me to give an interpretation about whether I indeed should have seen it in this direction, because actually if I look at my effects on a whole level, I'm seeing both.
But just following up on that, have you compared then the result with other neuroimage paper you presented for Mariana Babo-Rebello on the internal versus external spontaneous thoughts?
Yeah, so I compared to see whether the clusters that we are getting are similar, and also the topographies just on in the electrode space. And it seems to be that, first of all, the clusters seem to be slightly different, and then the source reconstruction also gives us slightly different sources. So there could be two things here. Either we're really tapping into a different mechanism, because here we're asking a different question in a different context, but there's also this comparison between EEG and MEG, which might make things a little bit difficult.
Thanks.
Thank you very much. I do think that was all questions. Thank you again to the speakers and to all our attendees. Well done, everyone. Just a quick note.